Hello everyone, in this video we're going to program the ArduinoUNO board with the Blink program written using assembly on the Atmel Studio 7. In the previous video I've shown you how to program the ArduinoUNO using the Atmel Studio 7. This time we're going to replace the Blink program with a program written using assembly. Program written using the high-level language such as this Blink program, which is written using the Arduino C, will normally compile to become very long machine code, which are very inefficient and unoptimized. If we look at the assembly of this program, you can see that the Blink program is translated into a very long assembly program. Okay, and this very long assembly program is translated into or occupied a large amount of the flash memory or the program memory of the microcontroller. In this video, we're going to see how we can write the same Blink program but using the assembly directly. The AVR processor of the Atmega 328P has over 120 assembly instructions. To write a program using assembly, the understanding of these instructions are needed. We can learn about the instructions from the instruction manual, okay, which describe what each and every instruction does. Or we can go through the internet and look for an example code and learn from there. If you look at the first instructions of the Blink program of the Arduino, okay, we can see that there is a jump JMP 5C instructions. Okay, this jump 5C instructions is translated into a machine code of 0C945C00. Okay, and this machine codes is actually there inside the flash memory of the Atmega 328P. Okay, since the jump is the first instructions, okay, the instructions will be stored at the address 0 of the program memory. So you see 0C945C00 there at the very first memory location of the flash memory. If we look at the manual for jump, okay, you can see that jump, the description for jump is jump to an address within the entire 4 million words of the program memory. This manual also tells us how many clock cycle is required to execute the instruction jump and what is the size of the instructions. Okay, the size is 4 bytes. It also shows what is the status registers affected and how the syntax is written and the allowable value for the operands. For the case where K is 5C, okay, the value for K for the 32-bit opcode that is generated from jump instruction would be 0, and at the end, the last 8-bit, we would have 5 and C. If we press the value into the calculator, okay, which is 1001, 0100, 0000, 1100, 0000, 0000, and here 5 is 0101 and C is 1100. You will see that the instructions in hexadecimal is 940C005C. And because Atmega 328P is a little endian processor, you can see that this instructions is stored in reverse. And you get 0C945C00. Okay. In addition to knowing the assembly instructions, We also have to understand how the pin of the Atmega 328P is controlled in order for us to create the Blink program. Looking at the data sheets of the Atmega 328P, you can see that Atmega 328P microcontroller consists of several I/O modules. Okay, you have the ADC, you have the timers, you have the communications modules, and many more. If we look at the I/O ports in details, you can see that every pins of the ATmega 328P is controlled using 3 registers, okay, which is the DD registers, the port registers, and the pin registers. Analyzing the circuit quickly, you can see that if you set DD as 1, we would enable this tri-state buffer that would allow any signal written into the port registers to be the output signal. And if you set DDR to 0, the port will be blocked, and whatever signals coming from the input pad would reach the pin registers, and we can read the input signal from these pin registers. Going further down, you can see that in order to set a pin as an output, we have to set the DD registers to be 1, and to set the output to be low, we write 0 to port registers, and to set the output to be high, we set 1 at the port registers. All the registers of the Atmega 328P are 8-bit. For this DD registers, for example, okay, DD here stands for data directions, and X here represents the port. You have port B, port C, and port D, and N here represents the number of bit. Okay, it could be 0 to 7. If we look at the schematic of the Arduino, okay, and we want to control the LED of the Arduino, let's zoom there. You can see that the Arduino onboard LED is actually connected to a signal SCK, and this signal SCK is actually connected to the pin 13 of the Arduino. Okay, and at the same time it is connected to the port B5 of the ATmega 328P. Hence, in our assembly, what we want to do is to set the bit 5 of the DDB registers, and then we want to toggle the bit 5 of the port B register. Okay, now let's try to write our assembly program. First, go to New Project, and then choose Assembler Project, name the project, and then choose the Atmega 328P, and we can start writing our assembly. Okay, in order to write to the port and DD registers, we can use the instruction called out, and instruction out takes in the address of the registers, which is DDB and port B, and then it takes the register, the value of registers. That means we have to set the value of registers in advance before writing it to the DD registers and the port registers. Okay, what we can do is to do LDI, or load an immediate value or integer value into one register, okay, say register 20, and we want to load a value of, okay, every register is 8-bit, and we want to set the 5th bit, bit 0, bit 1, bit 2, bit 3, bit 4, and bit 5. We want to set bit 5 to be 1. So we load the value into R20 and then out the value to the register DDRB and write the value of 20. And then what we want to do is we want to loop, okay, to start our loop. And in the loop, we want to write to our port B the same value, R20. And after that, we want to have a delay and then write the value of 0 into port B. Okay, since you cannot write R20 here, okay, we have to initialize another register with another value of 0. You can do LDI R21 0, okay, and then write R21 here. Okay, so R20 has the value of bit 5 of 1 and R21 would have the value of bit 5 of 0. This is actually equivalent to this 0. Okay, so we are toggling 0 and 1, our port B. And after that, we'll have another delay. And finally, what we want to do is we want to jump back to the toggle high. Okay, so we use our jump loop. Okay, and now what we have to do is to program the delay. There are several ways to create delay. The best or the most recommended way is to use timer modules and interrupts. If we do this, then while the timer is running, the processor can be used to do something else. But the easier way would be to simply write a simple loop using the assembly. We know that Arduino Uno is clocked with a 16 MHz clock. Since mostly all the instructions of the Atmega is executed in one clock cycles, the loop that we want to code will have to make millions of looping to get the delay of around 1 second. But for this, we will just copy the code that I have written earlier. Okay, and this subroutine have to be called from between the on and off. So we can do call delay, and here call delay. Now let's try to simulate this code. Okay, choose the simulator. Okay, and the first thing that we can see is that the assembly or the machine code that is stored inside the flash is now much simpler. Okay, only a few lines compared to the blink code of the Arduino written in C. Okay, now let's try to program the Arduino. Okay, let me stop the debugger and we use the external tool that we have set before, then click OK. And you can see now the Arduino is blinking with roughly 1 second delay. Let's try to make the blinking faster. Okay, let's change this to half of the number. Program. Okay, you can see the blink is now slightly faster. And if we make this smaller, and you can see that the blink become much faster. Okay, so that's it, how we write a blink using assembly.